Welcome to another deep dive. Today we're diving headfirst into a real cosmic mystery. What came before the Big Bang?
It's a question that's had cosmologists scratching their heads for as long as we've known about the Big Bang itself.
It's kind of like trying to imagine, I don't know, what was south of the South Pole, right?
Exactly. It's pushing the boundaries of how we understand space and time.
And to help us navigate this mind-bending territory, we're turning to, well, who else? The one and only Brian Cox.
Always a good choice for these cosmic conundrums.
He's got this great YouTube video where he breaks down some seriously complex stuff. But before we get too deep into the weeds, let's start with the basics, shall we? When we talk about Big Bang, what are we actually talking about?
Right. Because most people, when they hear Big Bang, they picture this massive explosion.
Yeah, like a firework going off or something.
Exactly. But as Cox points out, it's not really an explosion in the traditional sense. It's not like something exploded into something else.
So it's not like a grenade going off in an empty room.
Not even close. It's more accurate to think of it as the beginning of the universe's expansion from a state that was unbelievably hot, unbelievably dense.
Okay, so instead of an explosion in space, it's more like the expansion of space itself.
You got it. And everything, all the matter and energy we see today was packed into this incredibly tiny, incredibly hot, dense point.
So we're talking smaller than an atom, right? It's hard to even fathom.
Oh, way smaller. And from that tiny, dense state, the universe started to expand. And not just expand gradually, but incredibly rapidly.
And that's where we get into this idea of inflation, right?
Yeah.
This period of mind-bogglingly fast expansion in the very first moments of the universe's existence.
Precisely. And when we say moments, we're talking about a fraction of a second, so small it makes your head spin.
It's like trying to imagine the smallest unit of time imaginable and then dividing it by 1 billion.
Something like that. But here's the thing. As crazy as it sounds, this idea of inflation isn't just some wild theory physicists cooked up. We actually have evidence to support it.
Really? So we're not just talking about math equations and theoretical models here. There's actual observable proof.
Well, we can't go back in time and witness inflation firsthand.
Right.
But we do have something pretty amazing. The cosmic microwave background radiation.
Ah, right. The CMB. It's like a faint echo of the Big Bang, right? Like a baby picture of the early universe.
Precisely. And you know what's even cooler? The CMB isn't perfectly uniform. There are these tiny variations in temperature and density.
So it's not just a boring static picture. There are actually patterns and variations we can study.
Exactly. And get this, those patterns actually line up with what we'd expect to see if inflation had actually happened. It's like finding fingerprints at a cosmic crime scene.
That's incredible. So by studying these subtle variations in the CMB, we're getting glimpses of what the universe was like just a tiny fraction of a second after the Big Bang.
And those glimpses are telling us that something truly remarkable happened in those earliest moments, something that dramatically shaped the universe we see today.
It's like we're piecing together a giant cosmic puzzle, and inflation is one of those key pieces that helps everything else make sense.
And thanks to incredible instruments like the Planck satellite, we're able to study those pieces with amazing detail. We're literally looking billions of years back in time.
It's mind-blowing. But if inflation is this period of rapid expansion after the Big Bang, it still leaves us with the big question, what happened before that?
Okay, so before the Big Bang, before inflation, what are we even talking about here? I mean, it's already hard enough wrapping my head around the idea of the universe being smaller than an atom.
Right. Like, where did that tiny, dense point even come from?
Exactly. And is it even possible to talk about it before, when we're dealing with the very beginning of time itself?
You're getting into some seriously deep philosophical territory there. But that's what makes this whole topic so fascinating, right?
Absolutely. We're trying to push the boundaries of what we know, of what we can even imagine. Exactly. And while we don't have all the answers, or maybe even the right questions yet, there's some really intriguing ideas out there. Have you ever heard of string theory?
String theory. Okay, I'll admit, that one's always sounded a little intimidating, even to a space nerd like me. Like, I get the basic idea, tiny vibrating strings of energy instead of particles, but then things start to get really complicated really fast.
Oh yeah, string theory can definitely get pretty out there. But at its core, it's an attempt to create a theory of everything. A single framework that can explain all the forces of nature, from gravity to the subatomic world.
Okay, so like a grand unified theory of physics, that's a pretty ambitious goal.
You could say that. And one of the most mind-bending aspects of string theory is that it requires the existence of extra dimensions beyond the 3 spatial dimensions we experience every day.
Right. Up, down, left, right, forward, backward. And then what? There are more. My brain already
I
hurts.
know, right? It's hard to even picture. But according to string theory, these extra dimensions are curled up or compactified so tiny we can't perceive them directly.
Okay, I'm trying to imagine a fourth dimension, a fifth, a sixth. My brain is officially fried. But how does this all tie back into the Big Bang, into what might have come before?
So, in some versions of string theory, these extra dimensions aren't just some mathematical quirk. They allow for the existence of objects called branes.
Brains. Okay, now you're really losing me.
I promise it's not as complicated as it sounds. Think of branes like giant cosmic sheets or membranes floating in this higher dimensional space.
Okay, so like our universe is a sheet, and there are other sheets out there, other universes maybe, all existing simultaneously.
That's the basic idea. And here's where it gets really interesting. These branes can interact with each other. They can even collide,
Collide, like a cosmic fender bender.
more like a cosmic cataclysm. And some physicists believe that the Big Bang itself might have been the result of a collision between two of these branes.
Whoa, so not the beginning of everything, but just a really, really big event in a much bigger multiversal picture.
Exactly. It's like those two sheets of paper coming together and up, bam, is creating our universe as we know it.
Okay, now that's just mind-blowing. So we've got inflation possibly leading to a multiverse, and we've got brain collisions potentially causing big bangs. Are we any closer to figuring out which, if either of these ideas is right?
Well, that's the million-dollar question, isn't it? The truth is, we don't know for sure yet. Both of these ideas are still very speculative. But that doesn't mean they're not worth exploring.
I guess that's what makes cosmology so exciting, right? We're constantly pushing the boundaries of what we know and what we think we know.
Exactly. And who knows what amazing discoveries await us as we continue to delve deeper into these mysteries.
Speaking of mysteries, we've talked a lot about what might have come before the Big Bang, but what about the universe we live in now? Just how big is this thing anyway? It's like every time we talk about this stuff, I end up feeling so, I don't know, insignificant, like a speck of dust in this vast, unknowable cosmos.
Well, you're not wrong. But hey, that's part of what makes it all so awe-inspiring, right?
Totally. But it does make you wonder, just how big are we talking here? What's the actual size of this universe we're calling home?
Well, the observable universe, so that's the part we can actually see from Earth, that's a sphere about 94 billion light years in diameter.
94 billion light years. That's, okay, my brain just turned inside out.
It's a number that's almost impossible to grasp, isn't it? But think about it this way. The light reaching us from the edge of the observable universe, it started its journey billions of years ago.
So we're literally looking back in time when we look at those distant galaxies.
Exactly. We're seeing them as they were billions of years in the past. It's like having a time machine built into our telescopes.
That's so cool. But it also makes me wonder, if that's just the observable universe, does that mean there's more out there beyond what we can see? Like, are we just stuck with this limited view?
That's the million-dollar question, isn't it? And the truth is, we don't know for sure. But here's the thing. Our best measurements suggest that the universe is either a whole lot bigger than the observable universe or even infinite.
Infinite. Okay, now we're really venturing into the realm of the unimaginable.
I know, right? It's a concept that kind of breaks your brain a little, but think about it.
Yeah.
If the universe is infinite, then everything we know, everything we can observe, is just an infinitesimally small part of something much, much greater.
It's almost too much to comprehend. And it makes you wonder, what does it all mean? If the universe is infinite, if it goes on forever, what's our place in all of this?
That's a question that philosophers and scientists have been wrestling with for centuries. And you know what? I don't think there's a single right answer.
I guess that's part of what makes it all so fascinating, right? The mystery, the unknown. It's what keeps us exploring, keeps us asking questions.
Exactly. And who knows? Maybe someday we'll have some of those answers. Or maybe we'll just keep uncovering more questions, more mysteries to unravel.
Well, folks, there you have it. Another deep dive into the cosmos, leaving us with more questions than answers, but hopefully with a renewed sense of wonder and curiosity about the universe and our place in it. Till next time, keep looking up.